outside today because they are running a saw in my house, working on my bathroom upstairs. So it sounds like, well, construction. So we are going to work outside on the back porch today. At least it's not raining. So hope you guys had a good first day of online learning, and I hope it wasn't too stressful. And I know some of you had trouble getting your assignments to upload and send. If you need to, take a picture and email them to me. The app is my preferred, but it's not the only way. And if you need help with the app, let me know, and I'll see if I can help you get set up too. All right, so I've graded most of your reviews, and for the most part, we did a really great job. I will be posting your grades tomorrow along with the answer key so that you can look. The only problem I have is I can't really figure out, without printing each of your papers, how to exactly mark which ones you missed. So if I post the answer key, I think we've graded enough together in class that you're going to be able to look at that and determine, oh yeah, she counted off half a point for this, or it was a point for that. But if you're confused, just let me know and we'll work it out. All right, well today we're going to move on with inequalities, and we're going to jump right in, book page 326. So I'll need you to open your book or use your online textbook to follow along. We're going to start on 326, and you're going to need a piece of paper to take notes. And this box on 326 is super important. This box up here on the top. You're going to refer back to this a lot during this lesson. So basically, we all know, we learned in elementary school, the alligator mouth wants to eat the bigger number. So we've got less than, because the number on this side is smaller than the number on this side. So that makes this a less than. Or we have greater than, meaning that this number is greater than the second number. Okay, and remember when you were little, they taught you like an alligator mouth. The alligator wants to eat the bigger number. There's your art lesson for the day. Mr. Zumwalt would be appalled. Okay, so next. Today we're going to add something new to that. We're going to add, not only could something be less than, it could be less than or equal to. And it could also be greater than or equal to. So as we move along through the lesson, that's what you're going to see. So our first example at the top says you would use a less than symbol if you have a word in your problem, or if you have wording in your problem like is less than or is fewer than. You would use a greater than symbol if you have wording in your problem that is greater than or is more than. Now, less than or equal to would be for is less than or equal to, or wording like is at most, or is no more than. So if you take a look in that box I just showed you on page 326, you're going to want to write those in your notes, because when we come time for our next quiz or quiz review, you're going to want these notes in front of you. And then greater than or equal to would be wording like is greater than or equal to, or is at least, or is no less than. So let's take a look. Example number 1, again, page 326. Example 1 says a number C is less than -4. So that's pretty straightforward. So we know that this number, so I'll make this example 1. This number C is less than -4. Okay, less than -4. So what's less than -4? -5, -6, because we're dealing with negative numbers. The higher the absolute value of a negative number, the smaller the negative number is. Okay, so C is less than -4. A number K, example 2, or example, this is 1A, this is 1b. A number k plus 5 is greater than or equal to. That's where we get greater than or equal to. It's kind of a combination of both symbols. Greater than or equal to 8. K plus 5 is greater than or equal to 8. So your options would be k plus 5 could equal 8 because it's greater than or equal to. But it could also be 9, 10, 11. So anything that would make this expression on the left be at least 8 or bigger than 8 would work. Okay, so now C says 4 times the number q. So 4q. And we remember that when we have a number and a variable side by side, we don't even need a multiplication sign. It just means multiply. And we always put the number first. I've seen a few people want to write Q4. It needs to be 4Q. Is at most 16. So it could be 16. So it could equal 16. But it could also be less than. So less than or equal to 16. So we're not actually solving these for example 1. We're just writing them as an expression. So try the 4 at the bottom, 1, 2, 3, and 4, at the bottom of page 326. Press pause, try them, and then start me back up when you think you've got them, and I'm going to work them for you now. Okay, hopefully you've worked them yourself, and now I'm going to show you what they should look like. A number n is greater than 1. Number 2 is 2 times, or twice a number p. Twice is 2 times, so 2p is fewer than 7. And number 3 says a number w minus 3 is less than or equal to 10. And number 4, a number z divided by 2 is at least 6. So it might equal 6, but it could also be greater because it's at least 6, can't be any less. So greater than or equal to 6. So take a look there for 1, 2, 3, and 4. Okay. All right, so that's how you just take those written expressions and turn them into numeric expressions. So the next thing we're going to look at is we're going to look at actually finding some solutions, some possible solutions. Pardon me. Now these could have more than one solution, and all the possible solutions are known as a solution set. So if you look at the top of page 327, it tells you right there what I just told you. A solution of an inequality is a value that makes that expression true, or makes the equation true, or makes the, in this case, inequality true. An inequality can have more than one solution, and all of the possible solutions are called a solution set. So the example that they give us in the box is they give us some possible values for x. So they give us a table and it says here are some possible values for x, 3, 4, and 5. And then it says the inequality is x plus 3 is less than or equal to 7. X plus 3 is less than or equal to 7. Hopefully you see that in your book. And basically it says, could I put 3 in for x and this inequality be true? So if I substituted 3 for x, it would be 3 plus 3 is less than or equal to 7. Well, 3 plus 3 is 6 is less than or equal to 7. And that's true. So yes, this is a possible solution. Yes. Now let's take a look at 4. If I subbed 4 in for x, I'd be at 4 plus 3 is less than or equal to 7. Well, 4 plus 3 is 7, and that's less than or equal to 7. So equal to there is an option. Now, if this just said 7 is less than 7, that would not be a solution. But because this has less than or equal to, that works. So yes, this is a possible solution. Now let's look at what happens when we try to put 5 in. You may have already figured out that if we try to put 5 in, 5 plus 3 is less than or equal to 7. 5 plus 3 is 8. 8 is equal to or less than or equal to 7? No. So this is no, not a possible solution. Okay? So we're going to work a few more examples. Then I'm going to do the exact same thing we did before. You're going to, after we do these next few examples, then you're going to try numbers 5, 6, and 7 by yourself. And then you'll put me on pause, and then you'll start the video back up whenever you're ready to see the answers. And when you think you're ready, then you can start on your homework. And that is Harper in the background, who has found a squirrel. And Harper doesn't realize she has no hope of catching the squirrel. It sounds like a duck, but it's really my dog. She can't bark. Okay, example 2. 2a says, x plus 1 is greater than 7. And then it gives me, you separate this by a semicolon. Hi, Harper. Hi, Harper. Come here. You gonna say hi to the kids? Come here. Oh my gosh. It says x is possibly 8. Okay, x is possibly 8. So let's look. So if we put 8 in for x, 8 plus 1 is 9, and 9 is greater than 7. So yes, this is a possible solution, because that inequality is true. 9 is greater than 7. Now, B says 7y is less than 27. And it says, remember, separate your possible solution with a semicolon, or your substitution for the variable with a semicolon. Okay, it says our possible solution here is y equals 4. So if we go back and we put 4 in for y, you're going to end up with 7 times 4, which is 28. And that would make this inequality. 28 is less than 27, and that is not true. So big buzzer on that one. No. Not a possible solution. And then C says z divided by 3 is greater than or equal to 5. And it says a possible solution for z is 15. So if I go in and put 15 in for z, I end up with 15 divided by 3 is greater than or equal to 5. Well, 15 divided by 3 is indeed 5, and 5 is greater than or equal to 5. So because of that equal to, this is a possible solution. If we did not have the equals to, it would not work. But because we do, and these are equal, yes, this is a possible solution. Okay, so press pause. Take a minute to work 5, 6, and 7 at the bottom of your page. Check back in with me as soon as you finish those, and you're ready to see if they're correct. You were fast. I wasn't quite ready. All right, so for 5, b plus 4 is less than 6. And it wants to know if 3 is a possible solution for 5, 6, and 7. So if I put 3 in for b, we would have 3 plus 4 is less than 6, and that would be 7 is less than 6. That is not true. So this is no for number 5. 6 says 9 minus n is greater than or equal to 6. Peyton, in the house. 9 minus n is greater than or equal to 6. It wants to know, again, if 3 is a possible solution. So that would be 9 minus 3 is greater than or equal to 6. 6 is greater than or equal to 6. And because of that equal to, this is now a possible solution. So yes. And then number 7, 18 divided by x is less than or equal to 10. If we put 3 in for x, 18 divided by 3 is 6, is less than or equal to 10. 6 is indeed less than 10, so this works. So this is, yes, a possible solution. Okay, so hopefully that was pretty straightforward, I hope. If you have any questions, as always, let me know. One thing that's going to be super important on your textbook assignments, please make sure that you put the proper heading at the top with the page numbers and the problems, so that as you're sending things to me, whether it's through the app or email or whatever, I can very easily look at your paper and say, that's page whatever, and enter that, because I'm getting, as you can imagine, all kinds of papers. So that would be fantastic. Our assignment for today is going to be page 329, and you're going to do problems 5 through 16, all of them, 5 through 16. Okay, so it's basically taking a word expression and making it a numeric expression like we did at the beginning. Refer back to example 1. And then for 11 through 16, it's got a little 2 out to the side, which means look at example 2. It wants you to tell me whether their given solutions work or not. So yes or no. Now, you can't just write yes or no. You have to actually work it out as I did with all the steps. Please don't just try to write it all on one line. Work it out. And please make your paper as neat as you can for me. I really appreciate it if you can, very clearly, this is 1 and this is 2 and this is 3 and this is 4, or 1, 2, 3, 4, not 7 and 11 and 12 and 10 and whatever. So, I hope you guys are having a great day. Harper, come here. Harper, come here. Betty, come here. Come say hi. Here's Betty. Betty's helping. Say hi to the kids. Say hi, kids. Oh, Betty wants to go eat some more grass. And here's Harper. Come here, Fluffy Harper. Say, bye, kids. Say, have a good day. Learn a lot.